So it's bright and early on a Friday morning here at DHS. Working on your twin. So yesterday, before I left, I got through 10. Start over on 11. You're supposed to graph this piecewise function. It's not a hard one. I mean, the idea is you make tables. That's the idea. I didn't put anything on here too bad. I don't think I did anyways. But anyways, you've got x. If you look at this guy, you've got input of x and you've got output of -5. And you're allowed to plug in a 0 and a 1. And both of them are going to return -5. It's a horizontal line, so y equals -5. So when x is 0, which it actually can be with a solid dot, I'm -5. 2, 4, right in there. And I continue that all the way to the right until I hit 1 with an open circle. It's kind of tiny. I am 4 minus 2x if I'm stuck between 1 and 2. So we got x and an output of 4 minus 2x, and I can plug in a 1, and I can plug in a 2. If I plug in a 1, I'm a 2. If I plug in a 2, I'm a 0. I believe. I'm pretty tired. But anyways, the point 1, 2 exists, and it is solid. And then 2, 0 exists, and it is also solid. And I'm looking at the inequality symbolism. Looking right here to decide if I'm open or closed. And so long as x is greater than or equal to 4, I have a value of 1. So there's a jump. And that continues on forever to the right. Doesn't stop. It says greater than equal, sorry. That should be greater than or equal to. That needs to be fixed. I have to go back and edit that. But that should be greater than or equal to. And there's a jump. And that's your piecewise function. Kind of hard to tell where you had holes there, but there was a hole here. 12, you're writing the equation for the piecewise function. She has 1, 2, 3 pieces. I'll just call her f of x. And I usually make the domain first. This piece is drawn from -infinity to 1. Think about it. If you think about intervals, because I know you like intervals, that piece is -infinity all the way to 1, inclusive. The inequality for that is that you're less than or equal to 1. This piece is drawn between 1 and 2. Open hole at 1, so therefore no equality. Closed hole at 2, have equality. This piece is drawn from 2 forward. So x is greater than 2. There's no equality because it's an open circle. Then you just kind of write the pieces. I didn't make this hard. I mean, this right here, this is the mom function. That is literally the mother function, x squared. That's all it is. This guy right here, it's 3. It's a horizontal line. You just look at the output. And this one, if you were to extend it on down here, is simply mother function y equals x. Nobody's trying to make it hard. You don't know that. You don't know jack. All right, which of the following sequences are arithmetic? Select all that apply. Arithmetic means to add or subtract. And what we're looking for here is a common difference. So here it looks like we have a common difference of 3. Yes, there's a common difference equal to -3. We're subtracting 3 constantly. This one does something funky. It loses 19, gains 21, loses 23. So from here to here, we lose 19, and then we gain 21, and then we lose 23. There is a pattern, but it's not arithmetic. There's no common difference. Oh, we got some decimals, but it looks like it's 0.2 plus 0.2 plus 0.2. So yes, common difference is 0.2. Oh, and then we got fractions. It's going 1, 1/2, 1/3, 1/4. This thing is losing a half, then it's losing a sixth, And then what's she losing? Probably a 12th. I don't know, I'm pretty tired. It's going from 4 over 12 to 3 over 12. Yeah, she's losing a 12th. So while there is some arithmetic happening, there is no common difference. That's a no. All right, write down the first 4 terms of the sequence defined by this guy. So if n is 1, your output is a 6 because you're using this top function. So base of 1 is 6. And from then on, subtract 3. So base of 2 is 6 minus 3, which is 3. Base of 3 is 3 minus 3, which is 0, because we're looking at the previous term. And the fourth term is 0 minus 3, which is negative 3. So there's your first 4 terms. Find the sum of the arithmetic sequence 22, 11, 0, negative 11, negative 77. Let's look at this recursively. Recursively, write out the whole thing. Looks like you're losing 11. And then you put it all together. I mean, I'll let you use a calculator on this test, because I know some of you just can't add to save your life. Negative 275. Wasn't a hard problem. Takes a minute. What I would have done is I would have figured out that the difference here, the range, is negative 99. I would have thrown negative 99 over 11, which means 9 terms, sorry, negative 11, plus the original, which is 10 terms. And I would have done 10 over 2 times 22 plus a negative 77. We'll get the same blasted thing. 10 over 2 is 5. Those two make negative 55, and that's negative 275 all day long. It doesn't really matter. It's not a hard problem. It's not. I didn't try to trick you. I didn't. All right, in a theater, there are 28 chairs in the first row. Each row has 4 more chairs than the previous row, and there are 15 rows. How many chairs are there in the theater? If you want to be recursive, be recursive. You know, you just kind of draw it out. You got 28, 32, 36, and you do this until you hit the 15th row. And then you add them all together. It's not that bad. If you don't want to be recursive, don't be recursive. If you want to be explicit, go to a sub n is a sub 1 plus n minus 1 times d. Figure out how many seats are in the 15th row by letting n be 15. They tell you there's 28 in the first, and the difference is 4. So the 15th row is going to be 4 times 14, which is 56, right? Pretty tired. 56 and add 28, 76, 84. Assuming I didn't make a mistake, and you should be checking me because I am wiped out. 46. That's wrong. Or is it? 46 and 28, 66. There's your problem. And 874. There you go. 74. Yeah, I'm good with that one. Anyways, time to use a formula. There are 15 rows, so the sum of 15 is 15 over 2. First row is 28. Last one is 74. Crank out the math here. You can use a calculator if you want. Just be careful about calculators. 24, 74 and 28 should be 102. Half of 102 is 51. And that's going to generate a good giant number there. 15 times 5 is 750. 750 plus 15, 765. Seems like a lot of chairs, doesn't it? But it starts off at 28 and it stops at 74. It's a good sized theater. It really is. I'm just going back and checking some math because I'm pretty tired. I was right the first time. That was 84. Ah, how did I screw that up? I don't know. So 84. Glad I'm checking myself. 28 plus 84. Cut in half times 15. 840. There we go. 840. Sorry about that. Now, next page.